Okay, let's start the stream. Talk to myself for a bit, then talk to a bot, then we'll do some development. Everything we do is available eventually on BioniChaos.com, so go check it out, provide your feedback. Okay, what is it we need to do? Okay, so which bot is better for voice? Bring up Perplexity as voice. Claude doesn't. Better synthetic EEG signal generator. Let's go EEG. Yeah, the search is not great. Well, yeah, optical illusions are relevant to neuroscience, kinda. So yeah, this thing doesn't fit the screen. That's the usual problem we are having. Why did we use Tailwind to begin with? I thought we're not supposed to be using Tailwind anyway. And ideally we have a animate button for this. Okay, so Perplexity, Gemini, or ChatGPT, which one should we use for voice? For voice model.
Synthetic biomedical data, such as EEG signals, are artificially generated patterns that mimic real biological data to facilitate research and development while preserving privacy and enabling algorithm training. Synthetic data is artificially generated to closely resemble real data, maintaining statistical properties and structure, whereas fake data is inaccurate or misleading information that does not reliably represent real-world data characteristics. Exactly. If you generate synthetic data from a dataset with issues, the problems can be reflected and even amplified in the synthetic data. It's crucial to first clean and pre-process the original data, ensuring it's accurate and representative before generating synthetic data for training to avoid perpetuating those issues. Yes, gener- generating synthetic data based on theoretical models can be beneficial as it allows you to define data characteristics and control for specific variables. However, it may not capture the complexities and variability found in real-world data. Combining theoretical models with real data helps to ensure that the synthetic data is both realistic and useful for training models.
Okay, actually forgot to turn my microphone off. So it was perplexity. I had a quick chat. You couldn't hear what I said, but just heard what the bot was responding. But from that, it's probably fairly clear what the questions were. Okay, so normally what we will do next. We'll load the EG synth locally. We might give the code to like a notebook LM equivalent. Notebook LM. Yeah, everything we do is eventually ends up on BioniChaos.com. So go check out the tools. This one, for example, EG signal simulation. It's generating synthetic data, not to be confused with fake data, as discussed with perplexity before. Okay, so it's a single HTML, which is great. This is awesome because we can pop it. We had a bunch of prompts. Where are our prompts? Okay, we'll use 2.5 Flash. Hey, we'll give it all the code. We will give it all the code. Okay, that might be too long. It does fit into AI Studio. So the conversation between a data scientist and a comedian about this project, the code. About this web application. Hey, can we also mention the difference between synthetic data and fake data, and also describe if the waveforms in these web applications are generated based on another dataset or just the theory behind EEG? Quickly. Okay, there's a lot of nonsense in it. Let's simplify the prompt real quick. regenerate this thing. Okay, we can try it. So I have seed and AV. Let's try that AI Studio. Now generating media. Speech generation. Okay, so I have seed. Which one? Which?
Ready to make something amazing?
What do you want to explore?
Got a project in mind?
Yeah, let's have this one for seed.
What's a skill you'd like?
What kind of problem could we solve?
What kind of project are you thinking of?
Okay, let's do this too. Yeah, we'll run it. I think we'll just start talking when the podcast is ready. Doing a synthetic podcast as well as a synthetic data generation. Also, while the podcast is being generated, we could also add an option for automating for a demo mode. Agent. Can you just explain real quick, how do we add a demo mode that will essentially showcase what this web application can do? So essentially we'll we'll move the controllers one by one continuously to showcase how the web application works.
I'll help you create a demo mode for the EEG signal simulator. We'll need to add a button and create a function that automatically demonstrates different features by cycling through various states and controls. Here's what we'll do. First, let's add a demo button next to the preset selector. Then, we'll create a demo sequence function that showcases different features. I'll make these changes to the code. Made changes. Now, let's add the demo functionality to the JavaScript code. I'll add it just before the initialization code. Made changes. I've added a demo mode that adds a Start Demo button next to the presets dropdown. When clicked, it cycles through a sequence that demonstrates different brain state presets: deep sleep, light sleep, relaxed, focused, EMG artifact effects by gradually increasing and decreasing muscle artifact, EOG artifact effects by gradually increasing and decreasing eye blink artifact, individual.
Yeah, that was Claude Sonnet 3.5. Can you just, in a few sentences, just a quick response? The position of the button is not great at the moment. Any suggestions as to how we can place the demo button better? Also, can we confirm, are we moving one controller at a time, or are we changing different controllers at the same time? I did get the last bit, but let's see if it can.
Currently, the demo cycles through multiple changes, first through presets, then EMG/EOG artifacts, and finally individual waves. To make it clearer, we could slow it down to focus on one control at a time. For the button placement, I suggest we move it to a more prominent position at the top of the controls, above the presets. Here's the change. Made changes. The button is now full width and positioned at the top of the controls panel, making it more prominent and clearly separate from the presets. Would you like me to also modify the demo sequence to focus on one control at a time with slower transitions?
Kim, also, we have another issue of the whole dashboard, the whole web application, the whole canvas. So the controllers and the two charts and the controls do not fit a single window. Any ideas how we could improve that? No, it might find multiple things at a time. Just not what
to make the
I asked
dashboard fit better in a single window, we can adjust the layout to be more compact and optimize the vertical space. Here's what we can do. Made changes.
I just hidden the stuff.
Now let's adjust the charts and controls layout. Made changes.
It's gotta fix the charts.
And let's make the controls panel scrollable. Made changes.
No, I don't like the scrollable, so nothing, no additional scrollers. We just want everything to fit nicely. You can use more space on a wider screen. Are we keeping those or getting rid of them?
I understand. Let's make it fully responsive without scroll bars by using the full width of the screen and adjusting the layout proportions. Here's the fix. Made changes.
So, Evie, you dragged me all the way to the Brainwave Bistro to talk about...
Wait, so I have the podcast ready. We'll listen to it in a sec. So it's just describing this web application. Notebook and LAM. Trying to... most of the time spending on fixing the layout of the page. Which is, yeah, waste of time, as far as I can tell. Which model is better at it? Claude is stuck thinking. Okay, Mila, okay, let's stop that for a sec. Let's give it to another model. And it's fairly straightforward. Let's do basic GPT 4.0. Can you look at the code and find any issues with the layout? We're essentially trying to simplify the layout and make the two graphs, especially on wider screens, make the two graphs and the controllers appear all together so they're all visible. Wait, I haven't finished talking. Make them all visible in one viewport so we don't have to scroll anything. Can you do that?
To simplify the layout and ensure that the two graphs and the controllers are visible in one viewport without scrolling, especially on wider screens, we can use a flexbox layout to arrange the controllers and graphs side by side. Adjust the proportions so that the controllers take up less space and the graphs are given more room. Ensure the layout is responsive, so it adapts well to different screen sizes. I'll make the necessary changes to the layout.
Okay, you can do it quietly as well. Can do it quietly. Well, okay, the original thing is better. And let's take that over prompt. Look, the can't find issues with the layout. Simplify the layout, make the two graphs and the controllers all visible in one viewport so you don't have to scroll anything. Let's go back. Restore checkpoint. We have trouble as per usual. We have everything in a single HTML, so we could potentially give it to someone else. Let's try actually AI Studio, give it to 2.5 Pro. No, 2.5 Flash should be fine. If something like this, isn't it? We'll add the prompt as a message at the bottom of the HTML code. Again, while it does it, let's just do the overview of what is it we're trying to do and why. So we'll have some professional podcasters doing it for us.
So, Evie, you dragged me all the way to the Brainwave Bistro to talk about brainwaves? I thought we were getting molecular gastronomy. This better be good.
It is good, Sid. It's scientifically good. See that website I sent you? The Advanced EEG Signal Simulator? That's what we're diving into. Think of it as a DJ mixer, but for your brain's electrical signals.
A DJ mixer from my brain. So I can finally drop the sickest delta wave beats for my morning commute? My sleep apnea is gonna rock.
Exactly. Or more accurately, you can simulate dropping those beats. This isn't actually hooking up to your brain, thankfully. It's a tool for exploring what EEG signals look like.
Okay, so I'm looking at these charts, and it's all squiggly lines and colorful blobs. Explain it to me like I'm a particularly dense, albeit charming, neuron.
All right, dense but charming neuron. On the right, you've got two main graphs. The top one, the power spectrum, is like a musical equalizer for your brain. It shows you how much oomph, power, different frequencies of brain activity have. Are you chilling with slow, deep delta waves or buzzing with fast, alert beta waves? This graph tells you.
So if my beta waves are off the charts, I'm basically a human espresso machine. Got it. And the bottom graph? More squiggles.
That's the simulated EEG waveform, or the time domain. Imagine listening to the full song produced by your brain's orchestra. It's the raw, jumbled voltage fluctuations over time. The actual EEG signal you'd record from a person's scalp looks a lot like that.
So the top one is like looking at the sheet music, and the bottom one is actually hearing the symphony. But it's a symphony played by like a million tiny, slightly drunk conductors, right?
Excellent. And that's where the simulator's magic comes in. On the left, you have your conductor controls. You can adjust the tempo, frequency, the volume, amplitude, and even how messy each section of the orchestra is, bandwidth, for delta, theta, alpha, and beta waves.
Wait, delta, theta, alpha, beta? Those are the brainwave bands, right? I vaguely remember them from that one documentary where they hooked a guy up to electrodes and he started levitating. Or maybe that was a fever dream.
Probably a fever dream, but yes, those are the main ones. Delta, super slow, deep sleep. Theta, drowsy, light sleep, deep meditation. Alpha, relaxed, calm, meditative, eyes closed. Beta, awake, alert, focused, active thinking. There are gamma waves too, but this simulator focuses on these four for clarity.
So I can crank up the deep sleep preset and see a massive delta spike on the equalizer, and then I can watch the raw signal on the bottom turn into a slow, lazy river?
Precisely. And then the fun part, artifact simulation.
Artifacts? Like ancient Egyptian brainwaves? Is my brain secretly storing the blueprint for the pyramids? Or maybe that was a fever dream.
Not that kind of artifact, Sid. In real EEG recordings, you often pick up electrical noise that isn't from the brain. Things like muscle movements, EMG, or eye blinks, EOG. This simulator lets you dial those in. Try adding a lot of EMG. You'll see a lot of fast, chaotic noise on the signal and a broad hump across higher frequencies on the spectrum.
So I can make my simulated brain signal look like it's having a seizure while also trying to read a very blurry menu. Fascinating. But Evie, here's a crucial question from a professional purveyor of fabrication. Is this fake data? Like, is this the scientific equivalent of CGI for brains?
That's an excellent question, Sid. And that brings us to a key distinction. This is synthetic data, not fake data.
Aha! What's the difference? Synthetic sounds like fancy fake, like artisanal plastic.
Not at all. Fake data often implies data that's been fabricated to deceive or to support a predetermined, often incorrect conclusion. It's actively misleading.
So, like a politician's opinion poll.
You could say that. Synthetic data, on the other hand, is deliberately generated based on known principles, rules, or mathematical models to mimic the characteristics of real data. It's transparently artificial, but designed to be representative.
So, this isn't trying to trick anyone into thinking it's a real brain scan. It's more like a highly detailed interactive diagram.
Exactly. We know the mathematical properties of sine waves, which are the building blocks of these brain waves. We know the general frequency ranges and amplitudes for delta, theta, alpha, and beta. This simulator combines these theoretical components. It then adds noise, artifacts, based on how those artifacts are known to manifest in real EEG. It's all grounded in the underlying theory of EEG signal generation and characteristics.
Got it. So it's like a meticulously crafted model train set, not a hastily photoshopped picture of a train. It looks like a train, it acts like a train, but you know it's not going to take you to Schenectady.
Perfect analogy. And to answer your other question, no, the waveforms here aren't generated based on a specific, previously recorded dataset. Instead, they are built from the ground up using fundamental signal processing principles. Each brainwave is essentially modeled as a series of slightly randomized sine waves within a specific frequency band. That's why we have bandwidth controls, not just a single frequency.
So the simulator isn't just replaying a recording of someone else's brain. It's essentially building a brand new theoretical brain activity moment by moment based on my settings. That's oddly profound.
It is. This makes it incredibly valuable for learning and research. If you're developing an algorithm to detect alpha waves, you can use the simulator to generate a signal with a known alpha wave presence and test your algorithm's effectiveness. You have the ground truth because you built the signal yourself. In real EEG, finding that ground truth is often a huge challenge.
So I can make a perfectly alpha wave dominated brain, run my hypothetical meditation app algorithm on it, and see if it correctly identifies the chill vibes. If it works here, it might work on a real human who's probably just thinking about their grocery list.
Precisely. It gives you a clean, controlled environment to understand complex phenomena before diving into the messy, unpredictable world of real human brains. It helps build intuition. The A Deeper Look section even explains why the actual signal spectrum might look different from the ideal overlays due to constructive and destructive interference, a fundamental signal processing concept.
Yes, the podcast section. I appreciate that you've got an audio explanation for us auditory learners, or for people who are just too lazy to read, which, coincidentally, describes most of my audience. So, to sum up, this web app is a teaching tool, a testing ground for brain tech nerds, and it helps you understand why your sleep app keeps telling you you're restless when you just blinked really hard.
That's a perfect summary, said. It empowers people to demystify EEG data and explore the intricate world of brainwaves in a hands-on way. And who knows, maybe it'll inspire someone to develop the next breakthrough BCI.
Or at least a really good brainwave DJ set. Thanks, Evie. Now, about that croissant, can it simulate a full night's sleep for me? Because I've got a gig tonight and my delta waves are doing the Macarena.
We're working on that, Sid. One synthetic brainwave at a time.
Yeah, it was a notebook LM equivalent. And there's a human in the loop. If you have any questions, go for it. Go for the chat. Otherwise, we will move on. Okay, so we're actually trying to do two things at the same time. That's probably why we didn't succeed in either of them. One was, let's create a copy of the HTML so we have some sort of version control manual. Okay, one was the layout. Did it fix the layout? No, it didn't. And where did the demo mode come from? Yeah, so we were adding a demo mode for this thing, so I don't have to manually change anything. We can just press the demo mode button and we'll do it for us. That one was sorting the layout of the page. Don't know what's going on. Yeah, the layout is pretty bad. The layout is pretty bad. It's not much better than the original one. It's not much better. Which other model? Okay, so when you find any issues with the layout, essentially try to simplify the layout. Make the two graphs and the controllers visible in one viewport, so we don't have to scroll anything. Also, the demo. I thought we removed it. Now we have the demo button. We have a run demo function. Also, the demo functionality was added quite recently, so we need to make sure it's working correctly. Okay, we can give it to 1. Shall we move it into the canvas? Can it take that much code? Yes. No, the message was too long. It cannot. The only thing that can deal with it really is AI Studio. And let's do 2.5 Pro. This might take a while. There's a human in the loop. Let me know if there's any questions. Everything we do eventually goes on to BioniChaos.com. Go check it out, provide your feedback. Have a list of featured tools: cochlear simulation, ECG simulation, cochlear insertion, cochlear implant, electrode array insertion, rhythm scan. We're actually training models quite successfully, so they're performing pretty well. All the results are there. The Python code is on the page as well. This is on EEG data and not synthetic. So, and that's the thing with synthetic data, that's what Perplexity didn't mention before, is that if we add synthetic data to the mix, we could actually enhance the data set, make the training more accurate. So for example, we could actually see where the training is failing and generate more examples of that sort. So so during training, the model knows better. Yeah, I'll need a bot to explain it properly. Maybe we can do it later on. Now the question is if so those are seizures. Currently in the simulator we don't have an option to add seizures, so this is something we are looking into. If you have any ideas, let us know. Someone who has lots of ideas is Gemini. And let's copy. And let's click new. Grab the code. Let's run it in the server. Okay, try to improve stuff. Kind of mixed success. It did 3 columns. Okay, I understand, but the 3 columns don't really fit well. Yeah, the demo is working. What did it say anyway? Adding, removing muscle, that's fine. The change is minimal but has a significant impact on the usability. Well, yeah. And there were no issues found in the demo mode. Yeah, really dealing with stuff we don't want to be dealing with. Yeah, I'm not sure if it's better. It's probably not. So I'm having trouble fitting the whole thing into the screen. The only solution will be start adding tabs, which I'm not a big fan of. I do not like tabs. So the demo mode is nice. The other thing with the demo mode is that if the user is not interacting. Also, though, in addition to the demo mode, can we add the functionality that when the user is not interacting with the page for more than 5-10 seconds or so, let's say 10 seconds, the demo mode will start automatically, and if the user interacts with the page again, the demo will stop. So I'll add it to the prompt, but we'll probably have to give the whole thing to another agent. Another agent. The layout. What do we want from the layout? What do we want? When do we want it? Okay, so we have the demo mode button. We have the demo mode button. Actually, GPT should be better with images, right? No, actually, let's do stream or share screen with whichever model. Hey, can you describe what's on the screen in one sentence?
I'm unable to disprove anything on the screen. The image shows an advanced EEG signal simulator with various settings and graphs, but it doesn't present any claims to be disproved.
Okay, forget about disproving any claims. That was a misunderstanding. Can we move on? Can you describe the layout of the page?
Certainly. The page is laid out with controls on the left and graphs on the right. On the left, there's a brain state presets dropdown.
Yeah, just a
Artifact
general overview of the layout. How good the layout is.
The layout appears functional and well organized, with clear sections for different controls and visual output. It seems easy to navigate and understand the purpose of each
Okay, the
component.
problem with it currently that it's zoomed out to like, was it 25, 30%?
It looks like the problem is that the power spectrum frequency domain graph is zoomed out. The speaker mentions it's at around 25 to 30% zoom.
Now everything is zoomed out, so how do we make it, how do we condense it so it appears, so all the controls and the two graphs appear in one viewport?
To condense everything into one viewport, you could try using the Reset button next to the zoom controls for the power spectrum frequency domain graph. This should bring both graphs and the controls into a more consolidated view.
What are you talking about? No. First of all, no. Second, we're talking about the entire page layout. Not the individual graphs. We're talking about everything together. So we're trying to avoid adding tabs for the two graphs. So essentially we want all the controls and the two graphs appear in one viewport. What model is this?
Based on the conversation and the visual information, it seems like the goal is to have all the controls and both graphs visible within a single viewport. This could be achieved by adjusting the zoom level of the page or rearranging the layout.
Yeah, we'll have to rearrange the layout. How would you do it?
Given the current layout with controls on the left and graphs on the right, you could consider reducing the width of the control panel to allow more space for the graphs. Alternatively, you could implement a tabbed interface or collapsible sections for the controls to free up vertical space for the graphs.
No, I think we can still fit everything together without hiding anything. So everything that is currently on the dashboard should be there. The control tabs are already pretty narrow. So I'm thinking doing something with the graphs and the arrangement of the controls. So we'll have controls on the side and on the bottom as well.
The speaker is considering a layout change where controls would be on the side and bottom, rather than primarily on the left. This suggests an attempt to maximize the space for the graphs.
Okay, so if we went for the graphs being in the oops, something went wrong. Resume stream. I'll share the screen again. Okay, so we're trying to improve the layout of this page. So we want the graphs to be in the middle and the controls around the two graphs. On wider screens, we want whatever horizontal stacking and vertical stacking on narrow screens. Can you write how to go about it to a developer? A brief for a developer to essentially what to do.
The user wants to improve the layout of the page by placing the graphs in the middle and arranging the controls around them. They specifically mention horizontal stacking for wider screens and vertical stacking for narrower screens, indicating a desire for a responsive design. They are asking for a brief for a developer on how to achieve this.
Yeah, that's right. Can you write one?
Certainly. Here is the developer brief for implementing the new layout. Developer brief, redesigning the advanced EEG signal simulator layout. Objective: to improve the user experience by centralizing the main display graphs and arranging control elements around them, with a focus on responsiveness for varying screen sizes. Current layout as observed. Controls are primarily located on the left side of the screen. Graphs, power spectrum, and simulated EEG waveform are on the right side. Desired layout. 1. Centralized graphs, the power spectrum, frequency domain, and simulated EEG waveform, time domain. Graphs should be the focal point of the page, ideally positioned in the middle. 2. Surrounding controls. All control elements, brain state presets, artifact simulation, fine-tune waves, and spectrum overlays should be arranged around these central graphs. 3. Responsive design. Wider screens. On wider screens, controls should be horizontally stacked or distributed around the graphs, e.g., some to the left-right, some above/below. The goal is to avoid excessive scrolling and utilize the available horizontal space efficiently. Narrower screens. On narrower screens, e.g., tablets or mobile devices, controls should vertically stack above or below the graphs to ensure all elements are accessible and visible without horizontal scrolling. Specific considerations. Maintain functionality. All existing sliders, drop-downs, checkboxes, and buttons must retain their full functionality. Clear labeling. Ensure all controls and graphs are clearly labeled as they are currently. Visual hierarchy. The new layout should maintain a clear visual hierarchy, making it easy for users to understand which controls affect which aspects of the simulation. Flexibility. The design should allow for potential future additions of controls or graphs without requiring a complete overhaul. Suggested approach for a developer. Utilize modern CSS layout techniques such as Flexbox or CSS Grid for robust and responsive positioning of elements. Implement media queries to define different layouts based on screen width. Consider using a component-based approach where each control section and graph is a distinct, reusable component. Please let me know if you would like any modifications or further details added to this brief.
Yes, it does know what to do. Question is, who should be the developer of this? It is the demo. Yeah, the demo is there in this version. So we currently have that 3-column design is not great. So try this one instead. The only thing that can contain this much text, the length of the code, 1,000 lines or so, is Google's Gemini essentially. So we need Pro or 2.5 Flash, or 2.5 Flash should be able to do it, shouldn't it? Let's try both. So we have been struggling with this for a while. Everything we do eventually available on BioniChaos.com. Go check out the website. Let us know what you think. Let us know what you think. Okay, so I have a new version of the code. Why do I have a bad feeling about it? Why do I... Is the demo? The demo is working. Should be working. Demo? Yeah, it is working. And we have the two versions. So we'll just, the way we develop is that, yeah, it's like vibe coding. We're not looking at the code, but then we'll have two versions. We'll compare between them, like actual testing, whatever is needed to test it properly, and then we'll choose one. So we'll have two versions of this code. We will test the new one. What just happened? Okay, we had something broken. Is it tailwind related to... Why do we have tailwind to begin with? Was it just a warning? Can we remove tailwind? And there's something wrong. So I like what it did. Well, not quite. Not sure. There's something wrong. No error. Yeah, the charts are loading. Oh, we also need to improve the can we also improve the location, the position of the start the demo button? We'll add that in there. Okay, there's something super weird. Also, there's something super weird with the demo when you switch tabs or in your browser and going back to the original one. There's something super weird is happening. Well, I like how it broke down the controllers, but. Oh, we haven't trouble. Anyone? Well, the thing is, if ChatGPT, it would not even fit the... Yeah, the message is too long. Perplexity, Java default. Oh, it's actually pasting it as text. The text is 28% over the limit. Right, so that's why it's added it as text as opposed to pasting it. Okay. Not reading the attached file. Blah blah blah. Do I have text to speech or something? No. No, because why? Why bother? Perplexed. Oh, no, they do. Like if I summarize it, what's there? There's a lot of nonsense in Perplexity, but there's no text to speech, which is a bit unfortunate. We can always use a demo functionality, layout issues, split focus responsiveness, visual hierarchy, central ground controls. Made a table with the issues. What on earth? Can it actually generate code? Can you regenerate the code? It's actually can, so why did you? It's kind of a bit lazy. Seems a bit lazy. Don't know what's up with my microphone. Losing sensitivity or something. Okay. So which one's better? Well, obviously this one's better because it's working. The second one, having trouble with the graphs. Okay, this is what Perplexity is suggesting for. This is quite nice. A simpler design. Did you get rid of Tailwind and other things as well? Did get rid of many things. Yes, that demo button can be standalone. The two graphs. This is much nicer. Yep. Where's the advanced thing though? Yeah, we did have the single tab for the customize button. Yes, we like the layout. Can we just make the two charts fit the screen? That's pretty much it. Yeah, if we have space on the other side of the charts, we can add more controls on that side. Okay, I don't think we'll be having much luck. We won't be having much luck, would we? The original one didn't have the demo mode as well. I'm not sure. It's either we're removing functionality and making it like fit the screen better. So we might have like a simplified version of it and then a more advanced, depending on the, I don't know, either automatically depending on the screen size or something down those lines. But yeah. And yeah, all we need is to get the prompt right. And make sure the demo is working correctly. Making sure the demo is working correctly. I think it is. So remove that for now. The location. So the demo button can be above the charts. And let's try this again real quick. Okay, can you explain what's on the screen real quick in one sentence?
The screen displays a power spectrum frequency graph and a simulated EEG waveform time domain graph showing brainwave frequencies and their simulation.
Okay, so if you wanted to display everything in one screen view, how would you go about changing the layout of this simulation page?
You could try rearranging the elements to a more compact layout, like placing the control panels to the side or below the graphs, and making the graphs responsive to fit the screen size.
Okay, can you be a bit more specific?
Sure, you could implement a multi-column layout where the fine-tuned waves and artifact simulation controls are placed on the left sidebar, and the graphs occupy the main area. This would allow all elements to be visible simultaneously without scrolling.
Can you view what's currently on the screen? All the elements. How would you rearrange them? Okay, can you describe the elements, and for each element tell me where would you place them on the screen so everything is visible, optimizing for wider screens.
Based on the current layout, I would rearrange the elements as follows. The brain state presets and artifact simulation controls would be placed on a left sidebar. The fine-tuned waves controls could be positioned below the graphs in the main area. The power spectrum frequency domain graph and the simulated EEG waveform time domain graph would be displayed prominently in the center or top part of the main area, making them easily viewable.
Wait, that doesn't make sense. So if we have the two graphs arranged vertically in the center of the screen, shall we then have the controllers on the left and right, not top and bottom?
Yes, that would make more sense. Arranging the controls on the left and right sides of the vertically arranged graphs would provide a more balanced and efficient layout, allowing for easier access to both the controls and the visualizations.
Okay, so how would you go about it exactly?
You could use HTML CSS to create a two-column layout. Place the brain state presets, artifact simulation, and fine-tune waves controls in the left column. Then place the power spectrum frequency domain and simulated EEG waveform time domain graphs in the right column. This arrangement will ensure all key elements are visible without scrolling.
Okay, wait a sec. Can we do it without columns? Yeah, can we do it without columns so it works on narrow screens as well?
Yes, you can achieve a responsive layout without fixed columns. You could use a flexible box layout, like Flexbox or Grid, in CSS. This allows the elements to wrap and adjust their positions dynamically based on screen size, ensuring all elements are visible on various screen widths, including narrow ones.
Okay, can you be more specific to the contents, the components on this page?
Certainly. For the specific components on this page, you could arrange the brain state presets, artifact simulation, and fine-tune waves controls within a flexible container on the left side or at the top if the screen is narrow. The power spectrum frequency domain and simulated EEG waveform time domain graphs would then be displayed in the remaining space, adapting their size and position to fit the screen. This approach ensures a responsive and user-friendly layout across different screen sizes.
Okay, let's try it out quickly. that the demo mode is becoming faster over time. I don't know why is that happening. We'll try fixing it next time.